Welcome to today's video on Unit 9, Part 4. We're going to talk about how to graph trigonometric functions, or basically review of what you accomplished last year. So we'll start with the sine function, and that'll lead into the cosecant because they are reciprocals. So remember, the x in y equals sine x represents an angle. And the y here in y equals sine x represents the y coordinate of the unit circle because that's what the sine of the angle equals. All right, so if we graph all the ordered pairs for all the quadrantal angles from negative pi to 6 pi, so negative pi, the sine would be 0. Negative pi over 2, it's negative 1. At 0, it's 0. Pi over 2, it's 1. Pi is 0. 3 pi over 2, negative 1. 2 pi, 0. And notice the pattern just keeps going. Just graphing all the quadrantal angles. So you notice it basically just repeats itself. It's one big wave like that. All right, so that is the sine curve. Now notice, because of all the repetition, the length of one cycle is what's called the period of the function. So the sine and all these trigonometric functions, when you graph them, are periodic functions. So the period is the time it takes to repeat one cycle. And when we graph it, our period that we're going to use, if you notice, from 0 to 2 pi. So that is one period of the sine function. That's why there's a little box there. Additionally, the amplitude is the height from the midline to the peak or the valley. So notice the midline is right here. That's the x-axis, right? So notice it goes up to 1 and down to 1. So notice the amplitude for the sine function is 1. So if you look at the graph, is the sine function 1 to 1? Well, remember, to tell if a function is 1 to 1, you do the horizontal line test. And notice it does not pass the horizontal line test. The cosecant is related to the sine in that they are reciprocals of each other. So they are reciprocals. So using the above, I could sketch the cosecant in a different color. I'll use red. Now everywhere the cosecant is 0, that means the reciprocal of 0 would be undefined and you would have a vertical asymptote. So everywhere the sine is equal to 0, the cosecant would be undefined. So notice all the asymptotes. And then the points, there, 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 and there. Now notice, since it's a reciprocal, notice here it's going up the parabola, so you could go down. Here it's going down, so it's going to go up. And you just continue the pattern. And that's what the cosecant graph would look like. So for the domain for the sine, if you notice the domain, you can put any number in, right? There's no undefined for sine. So the domain is negative infinity to infinity. The range, it's from negative 1 to 1, right? Goes up up to 1, down to negative 1. The period is 2 pi, and the amplitude is 1. That's how high or how low it will go. For the cosecant, however, the domain is all x, and such that x is a real number. However, x cannot equal multiples of pi, because every pi, there is a vertical asymptote. Notice 0 pi, pi over 2, 3 pi. So any multiple of pi, there's a vertical asymptote where k is an integer. The range, well, the range of the cosecant goes from negative infinity to negative 1, union 1 to infinity. The period is 2 pi, but there is no amplitude because it goes up forever and down forever. So there is no amplitude. Now, you can put like parentheses to say where the points, notice the points that are not vertical asymptotes would be, and that would be at 1 or negative 1. So they would go up and down to 1. That's where the starting point of the parabolas would be, the vertexes. For the cosine, the x represents an angle. The y represents the x coordinate. On the unit circle. And if we do the same thing going from negative pi to 6 pi, so at negative pi, it would be at negative 1, and then it'd go up, negative pi over 2 is 0, and then at 0 starts at 1, then it'd go down, so then the pattern just continues. Oops, sorry. Skipped one there. So notice the cosine curve looks like that. All right. So is cosine a one-to-one function? And just like sine, it is not. The secant and cosine are reciprocals. Using the above graph to sketch the cosine or the secant. Now remember, everywhere the cosine is 0, you're going to have an asymptote. So starting at negative pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2, 9 pi over 2, 11 pi over 2, all the asymptotes. And then the points, so you're going to make your parabolas just like the cosecant. You have your parabolas. That originate from the bottom and top points. This one go like that. This one goes like that. All right. So there's the secant, and notice domain of the cosine, negative infinity to infinity. It's all real numbers. The range, just like the sine, is negative 1 to 1. The period is 2 pi. The amplitude is 1. For the secant, the domain is all x, such that x are real numbers. However, x cannot equal. Now, the first vertical asymptote is at pi over 2, but then it would be adding multiples of pi from there, where k is an integer. And the range, same, is from negative infinity to negative 1, union 1 to infinity. The period is 2 pi, but there is no amplitude. However, the points that you use will go up 1 and down 1 from the midline. So now for the tangent, x represents an angle again. Y is now the ratio of y over x on the unit circle. Now, if you look at the graph of tangent from negative pi to 2 pi, so we go negative pi is 0. Negative 3 pi over 4 is positive 1. Negative pi over 2 is undefined, so you'd put a vertical asymptote. Negative pi over 4 is negative 1. At 0, it is 0. At positive pi over 4, it's positive 1. And at pi over 2, there's a vertical asymptote. Then 3 pi over 4 is negative 1. Pi is 0. 5 pi over 4 is 1. And then 3 pi over 2, vertical asymptote. And then 7 pi over 4 is negative 1. And then 2 pi is back to 0. So if you look here, it goes up from left to right like that. And like that. There's 2 full periods. And then this is going to be the start of a period. And this is going to be the end of a period right there. So there's your graph of the tangent function using all the quadrantal and pi over 4 angles. The domain, well, the domain is the x's such that x are real numbers. And notice the vertical asymptotes are, if you look at the first one's at pi over 2 and then you add pi, so x cannot equal pi over 2 plus pi k, where k is an integer. The range is negative infinity to infinity. The period, if you notice now, it repeats itself after pi, and there's no amplitude. No amplitude. Now, if you look at the cotangent, x represents an angle. The y represents the x over y ratio on the unit circle. Now, when you graph the cotangent the same way, their asymptotes start at negative pi. Negative 3 pi over 4 is positive 1. Negative pi over 2 is 0. Negative pi over 4 is negative 1. There's an asymptote at 0. Pi over 4 is 1. Pi over 2 is 0. 3 pi over 4 is negative 1. And then there's an asymptote at pi. 5 pi over 4 is 1. 3 pi over 2 is 0. 7 pi over 4 is negative 1. And then there's an asymptote at 2 pi. So it goes like this. Down. So it decreases from left to right, whereas tangent is increasing from left to right. So that you get 3 full periods in here. The domain are that it's x such that x is a real number. However, x cannot equal, and it's multiples of pi, starting with 0 and going to pi, where k is an integer. The range is from negative infinity to infinity. The period is pi, and there's no amplitude. So sine and cosine, remember, are the only ones that have amplitude. All right, so from your work last year, remember there are certain transformations that you need to look for. For example, if you look at the function, the number in front that's multiplied by the function is the a term, and that is going to make it either a reflection across the x-axis if the a is negative. Also, if the A term is greater than 1, it's a vertical stretch. And if the A term is less than 1, it's a vertical shrink, meaning the absolute value. So for example, if it's -5, the negative sign just talks about the reflection. The 5 is what you would determine the vertical stretch and shrink. So that would actually be a vertical stretch with a reflection across the x-axis. Horizontal stretch and shrink, if, remember, the reciprocal of the B term here, if it's greater than 1, then it's a horizontal shrink. And if it's less than 1, it's a horizontal stretch because you take the reciprocal. And we'll talk about that when we do some examples. Horizontal shift, left if h is less than 0, right if h is greater than 0 here. So now some terms. The phase shift is the same as the horizontal shift. So if there's a horizontal shift to the left, we say there's a phase shift to the left. So that is a fancy term in trigonometric functions for the horizontal shift. The amplitude is just the absolute value of A in the sine and cosine. So the amplitude is the same as the vertical stretch or shrink. And then we'll talk about how to find the period. And that's right here where the period is just equal to 2 pi over b, the absolute value of b. That'll tell you the period of the trig functions. So here's some steps that are outlined. So make sure you read those steps because we're going to use those to do the problems. All right, so number 1, the first step we're going to do is to use the even and odd identities to make sure that b is positive. So for example, here, the first thing we're going to do is we're going to factor out the term in front of the x. So we're going to take out the -1/4. And when you take out the -1/4, that makes this a positive. And then when you divide pi over 2 by 1/4, you get 2 pi. All right, now here's where you use the even and odd identities. When there's a negative, when you do cosine negative x, remember cosine is even, so that means cosine negative x is going to be the same as cosine x, so that negative sign basically in there can go away. So it's going to be the same as cosine 1/4 x plus 2 pi plus 3/2. So there's our equation that we're going to use to graph. So if it was an odd function, it would change this negative sign to a positive. So now we can find the period. Remember, the period is 2 pi over the absolute value of b, so it's 2 pi over 1/4, which is 8 pi. The phase shift is the horizontal shift, and notice that's to the left 2 pi because it's positive, right? Because that turned it to positive, so it's to the left 2 pi. Because think about the number that you would have to put in here to make it equal 0, and that would be -2 pi, which means you go to the left. The amplitude is the absolute value of -1/2, so it's going to be positive 1/2. So that's the amplitude. So now part C, it wants you to sketch the base graph with the period, amplitude, and reflection. So don't worry about the shifts. Just worry about the reflection. There is a reflection because there's a negative sign. It reflects the x-axis. So it means the y's are negative. That's what that means. The period is 8 pi, and the amplitude is 1/2. So we're going to start at 0. And we're going to just draw the graph with the amplitude and the period and the reflection. So if we start at 0, so now this will be -1/2 and positive 1/2. Those are our A's. Here's 0. and then 2 pi, 4 pi, so every mark will be 2 pi, 6 pi, 8 pi, right? So you can do it with the lines. You just got to scale your graph. And then, so at 0, normally for cosine it'd be at the top of the amplitude, but now because it's a reflection, it's at the bottom. And then it goes 2 pi, 4 pi at the top, 6 pi, and then 8 pi would be the last one there. So this is what the graph would look like, one period with just the reflection, the period, and amplitude. So now for part D, you use the shifts, the phase shift, the left 2 pi, and the vertical shift up 3 halves. And then you're going to draw the same graph, just shifted left 2 pi and up 3 halves. So that means that these marks, you're going to have to go to the left. So that's negative 2 pi, negative 4 pi, positive 2 pi, positive 4 pi, positive 6 pi. All right, and then it's going to go up 3 halves. So basically, if this was 1 half, then this is going to be 1, 1 and 1 half, 2. And then if it was down, so then basically every point is going to move up and over and up. So you're going to go to the left. So this is going to go to negative 2 pi. And then it's going to go up from negative 1.5 to positive 1. There you go. And then same thing with this point. It's going to go now to 0 and then up to 1 1/2. Sorry, I put that in the wrong spot. It should go up to 1 1/2. So it should go right here. There. All right, and then this one's going to go over to 2 pi and then up to 2. And then this one's going to go over to 4 pi and up to 1 1/2. And then the last one's going to go to 6 pi and then up to 1. And there you go. There's your end product for the cosine curve. All right, so try to do the same thing with the cosecant on the next two. I will post the answers for you to look at after you've done or tried the cosecant number 2 and number 3 and 4. I'll post those. All right, I'll just go through these. So here, -3 cosecant, notice you factor out the -4. And then cosecant's an odd function, so that means the negative would move to the front, and that makes it a positive. So it's going to be 3 cosecant 4 times x minus pi over 4 minus 1. So that means the period is 2 pi over 4, which is pi over 2. The phase shift is to the right, pi over 4. And the amplitude, there is none for cosecant. However, you know the points, because that's 3, are going to go up to 3 and down to -3. So now when you draw the graph of the cosecant, and remember the cosecant has an asymptote starting at 0 and going to pi and then 2 pi. So when you start at 0, and now the period is shorter by 4, so that means now that period ends at pi over 2. So if we start at 0 and say this is pi over 4, and then pi over 2, and then 3 pi over 4, just to say we went by pi over 4. But notice it'll end, you'll have a asymptote at 0, an asymptote at pi over 4, and an asymptote at pi over 2. Actually, I could have spaced that out a little better, but we'll make it work. So in the middle, so it started at 0. In the middle, it went up to 3. Because remember, this is based on the sine curve, right? So notice -3. So if you go up, down, down, up. So notice there's your sine curve that you could base it on. So you're just doing the reciprocal, which means that here's your point. So there's your parabola there, and there's your parabola there, because basically you're making it a period of pi over 2. There's no reflection, but there is a phase shift. Actually, phase shift we'll talk about in the next. So it's just the period of pi over 2 and the a term of 3. So there's what that is with that. Then for the next thing, you're going to take in the consideration, go to the right pi over 4 and down 1. So to the right pi over 4 means that you're going to move everything. So I'm going to space out a little better. So that's pi over 4, pi over 2, and then 3 pi over 4. So now everything's going to move, all of the asymptotes. So pi over 4, pi over 2, 3 pi over 4. And now the points are going to go down 1. So instead of at instead of at 3 and -3, it's going to go to 2. So in the middle here, 2, and then to -4. So then you're going to go up like that and down like that. So when you talk about the domain, that remember that means that x is such that x is a real number. And then the asymptotes are every pi over 4. So it's pi over 4 plus, actually, sorry, pi over 4, so it can't equal pi over 4 times k, because every pi over 4 is an asymptote, or k is an integer. The range, so you're going from -infinity to -4, union 2 to infinity. All right, for the tangent, you factor out, you factor out the 3/4. Now there's no negative sign, so there's nothing else to do. So the period, remember for tangent and cotangent, it's pi over b. So it's pi over 3/4, which is 4 pi over 3. The phase shift here is to the left pi. The amplitude, there is none, but notice the number in front is a 3. So we'll just keep that in mind. That sets the high and low for the pi over 4 angles. As far as what we have here, well, remember we have a period of 4 pi over 3. We have a reflection, because there's a negative sign, of the x-axis, and the a is 3. So remember, normally it's from negative pi over 2 to positive pi over 2 for the tangent. So if you multiply negative pi over 2 times 4/3, notice that gives you 2 pi over 3. So that means now instead of going from negative pi over 2 to positive pi over 2, it has stretched to 2 pi over 3. So each mark will be worth pi over 3. Make it a little bigger so you can see. And then here it's pi over 3 and 2 pi over 3. So that means the asymptotes now are at the end, at negative 2 pi over 3 and positive 2 pi over 3. That the point in the middle is still at 0, 0. But now pi over 3 is going to go up to 3. And notice it usually rises from left to right because of the reflection. It flipped. And then down to negative 3. And now it goes like this. Now, the next thing is the left pi and up 1. So if it goes to the left pi, that means you're you're going to the left 3 pi over 3. So that means now here's 1 pi over 3, 2 pi over 3, 3 pi over 3, 4, and then 5. So it's negative 5 pi over 3. There's 0. And then positive pi over 3, 2 pi over 3. So if it goes to the left pi, that means now instead of negative 2 pi over 3, the end is at negative 5 pi over 3. And then this last asymptote would be at negative pi over 3. And then everything, so this would be negative pi. Everything shifted over and up 1. So we have to go up 1 as well. There's 1, 2, 3, 4. 1, 2, 3. So everything went up 1. So the middle point now was up 1. So this point here was up 1 to 4. And this one here was up 1 to negative 2. So it goes like that. All right, the last one is the cotangent. The cotangent, we factor out the negative sign, or the negative 1/2. So it's going to be x minus 2 pi. Now remember, cotangent is odd, so that makes this a negative 4. The period is 2 pi over 1/2. So it's equal to, actually it's pi over 1/2. So it's equal to 2 pi. The phase shift is to the right, 2 pi. And the amplitude, there is none. But keep in mind that it's going to go up to 4 and down to 4 because the A is 4. So remember, the period is 2 pi. The A is 4. And there is a reflection. So that means instead of going down from left to right, it's going to go up. So with that in mind, we're going to start at 0, but now it's going to go pi and then 2 pi. And now you're going to have your asymptote at 2 pi and at 0. your middle point is pi 0, and then here it's going to go 1, 2, 3, 4. 1, 2, 3, 4. And now remember it's going to go this way, so it's going to go in the middle here and in the middle there. So it's going to go up from left to right because it's a reflection about the x-axis. So now the next thing you have to keep in mind is the right 2 pi, and then it's going to go down 3/2. So the right 2 pi means that now here's 0, here's pi, here's 2 pi. So then you have 3 pi and 4 pi. So everything now, the asymptote's moved over 2 pi. And then the point in the middle, which was at pi, is now at 3 pi, but it also went down 3/2. So if we make our scale, I'm going to space it out a little better. 2, 3, 4, 5. And then 1, 2, 3, 4. So now it went down 3/2. So it was at -4 here. So now it's going to go down 1, 2, 3, 4. So it's going to go down to -5.5. So it's below there. And then if I can get this to stay. Okay. And then here it's going to go down to there. So it was at 4. It's now going to be at 2.5 right here. So our graph, and then this is going to go to -1.5 right here, the middle point. So it's going to go up like that. And there you go. There's our cotangent. All right, so there's some graphing, some trig functions. Make sure you do the learning opportunities on that. And then I will see you on Zoom conference. All right, have a good evening.